Measuring plant biomass using harvest and estimation methods. The main approaches to measuring biomass on rangelands are harvesting, estimation, double sampling, and indirect methods. In this lesson, we will be focusing on harvesting and estimation methods. With the harvest method, plant materials are clipped and weighed. It's very straightforward. The materials are removed from the quadrat. Advantages of the harvest method are that it's a very objective measurement of plant biomass, and it's relatively easy to learn how to do it and how to do it consistently. The disadvantages are that it can take quite a bit of time to sample and separate species by clipping them out of quadrats. It depends on the density of the vegetation, how much biomass there is, but it can be quite time consuming, and so it's labor intensive. This can reduce the number of samples that can easily be collected in a specific length of time. It's also destructive. You are removing biomass, you're removing plants from the quadrats. And it can be very difficult to do for tall trees and shrubs. It's much better for herbaceous plants. The basic harvest method starts with positioning a quadrat on the ground and then making sure that we have determined which materials are inside the quadrat. Then we clip the biomass. You have to be clear on what your purpose for sampling is, because that can determine some of the protocol that you use. For example, if you're sampling plant production, then we would clip right to the soil surface. If we were sampling herbaceous forage, for example, we would then clip at 1 inch height above the ground. And if we were sampling browse, we would focus on those leaders and twigs and leaves that were produced by the plant that would be available to a foraging animal. After the material has been clipped, sometimes we have to take time to process it. It depends on if we're going to remove dead material or not. So if we're sampling annual production or the current year's growth, as these women are doing here, we would take time to remove the dead material before placing it into bags. Usually we sample by species, and so each bag would contain the biomass that's harvested from individual species. Once the material has been placed in the bag, we then weigh those bags in the field to get a fresh weight on that harvested material. Now, the overall goal is to estimate dry weight biomass of plants. In the field, the measurements that we take on the fresh weight or the green weight weigh more than the dry weight because of the plant moisture content. Depending on the plant species and also the time of year when we sample, plants can contain a fair amount of moisture, which can really influence the weight that we get in the field. And so we have to have a way of converting that weight to a dry weight basis. We usually do this by either oven drying or air drying our materials that we have harvested. And we prefer to oven dry material, but in the case that we don't have an oven available, we can take the bags and put them in a safe room like a lab where the bags are left open and the materials can dry out. An alternative to drying materials is to use calculated book values that can be found in certain references that use an assumed moisture content. Obviously, this is the least precise method that's available to determine dry weight. So there's two main approaches to determining dry weight. The first is to take all of the harvested material that's been put into bags, bring it back to the lab, dry it in an oven, and then weigh all of those materials. As you can see here, there's an oven full of bags of herbaceous material, and then each bag, which is clearly marked, is being weighed on a balance. An alternative approach is to take fresh weights on all of the materials in the field, and that's what we see these two individuals doing here. Then a subset of those bags that were weighed in the field are trucked back to the lab, dried, and then weighed subsequently. That gives us a dry weight and a fresh weight for those samples. Using the dry weight and the fresh weight, we can calculate a dry weight correction factor and use that correction factor to adjust the fresh weights that were measured in the field to dry weights. So let's look at how this is done. Here we see an example of 5 samples that were weighed in the field. So we've got 5 fresh weights, and then they were brought back to the lab, dried to a constant weight, and then weighed. We have a dry weight that has a greater precision than the weight that we measured in the field. That's okay. And we can then convert by taking the ratio of the dry weight to the fresh weight for a specific sample. In this case, 81% or 0.81 is the conversion factor. That means that of the fresh weight, the harvested material from the field in that bag, 81% of it was dry weight and 19% of it was moisture that has been removed through the drying process. We do this for each one of the samples. There's going to be differing amounts of moisture just based on sampling, and we then come up with an average value of dry weight, which was 79.4%, and a conversion factor of 0.794. We can then use that conversion factor on recorded fresh weights that we have from the field. These are samples that were not brought back for drying, but we can adjust them based on this average dry weight conversion. So for example, this fresh weight of 42 grams per plot would be adjusted to 33.3 grams per plot for that one sample. Remember that conversion factors need to be determined by species, because species differ in the amount of plant moisture that they retain, and depending on the time of year, some plants may be actively growing and have more moisture than other plant species. So conversion factors must be determined by species. Once we have determined our conversion factor and adjusted the weights of the samples that were measured in the field, we can convert those weights to estimate dry weight basis biomass on a larger area basis, such as kilograms per hectare or pounds per acre. With the estimation method, weights are estimated and they are not harvested except during training and for dry weight correction. So we just estimate the weights of plants in quadrats. The advantages of this are that it's quite rapid. This allows us to take a larger sample size. And also, it's not destructive because, except for during the training phase, plants are not harvested. The disadvantages are that it can be a subjective measure that can be inaccurate because of the estimation. It requires extensive training and calibration in order to improve the accuracy of individual observers' ability to estimate weight. And it can be very difficult to visually separate out biomass that's produced in different years. So if we're sampling current year's growth and we would want to remove the dead biomass from a previous year, it's easier to do that if you're harvesting because you can just pick it out of the material that you've already clipped. With estimating, it's a bit more difficult to separate out the dead material from the live material. Now, the way this is done is with the concept of weight units. We need to determine a weight unit for each one of the species. A weight unit can either be a plant part or a whole plant. And what we choose as a weight unit is going to vary with different species, and also it's going to vary for different observers because different observers are comfortable with different weight units. So let's take an example and look at this image here. We see a Cytodes gramma. This is an example weight unit of 25 grams. In this case, we have a weight unit of a typical plant that is 50 grams. And as you can see in the image here, these observers are testing their weight units by feel. We do this both by feel and by sight. And so sometimes you will take a weight unit that is something that's easy to multiply, but also something that you can consistently identify in a quadrat. And a lot of times we will do this by feel. Training is a very iterative process. First, you train on the individual unit before you start trying to estimate how much biomass there is in a quadrat. It's iterative, and the way this works is by first finding what you think is a weight unit, estimate the weight in that unit, clip it and weigh it, and then compare your estimate to what the actual weight is. You make an adjustment either to the size of what you choose to be your unit or an adjustment in what you think that unit should weigh, estimate on another plant, clip it and weigh it, and compare your estimated value to the weighed value. You repeat this process until the weight unit that you're estimating can be determined with a relative amount of accuracy. You repeat your training on different weight units for all of the species that you're likely to encounter in your quadrats. Once you've done that, then you can begin to estimate on a quadrat basis. When we record our data, what we do is we essentially observe a quadrat and count the number of weight units for each species that are in the quadrat. We sum the number of units and then record that number by species for each quadrat. It's important to remember that when we encounter plants, they're not always going to be in one plant equals one weight unit. You may have some plants that are slightly larger and some that are slightly smaller than your weight unit. And so we can estimate partial weight units. We essentially have to move around the quadrat with our hands and sometimes assume in our mind's eye sort of that this piece of plant here totaled with this piece of plant here is, say, 3/4 of a plant unit. So it's important to remember that you can use partial units. Once this has been done, we record all these data. It's important to remember to calibrate periodically during the day, because we can have estimation drift, where you may begin estimating very precisely at one point during the day, but by about noon or so, you may have started to either underestimate or overestimate plant biomass. And so we will stop and recalibrate by going through that iterative process of estimating and clipping and weighing, just to make sure that our estimates are still spot on. As with harvest, we need to collect a subset of the samples in order to determine dry weight conversion factors for each one of the species. So in this case, we will take a subset of plant material that has been estimated. We then harvest it, bag it, dry it, and weigh it in order to determine that conversion factor. Now, so far we've focused on estimating with herbaceous material, and it's a bit more tricky and a different approach with trees and large shrubs. In this case, the weight unit is usually larger, such as a branch, and there's got to be some training that's involved, but in this case, in this tree here, the weight unit of this branch is 2,000 grams or 2 kilograms, and then once you have that as what you're watching for, you would then count the number of weight units in an individual tree and sum those up. In this case, 8 weight units at 2,000 grams per unit would equal 16 kilograms for this tree. That's doing it on a branch by branch basis. Another way to do it is using your tree or your shrub as a unit. And in this case, you select a certain height tree. You may have multiple heights for a tree. And so in this case, what we see here is that this tree that is 15 feet tall carries a production weight of approximately 15 pounds of material, and these shorter trees have less material. Now we can see that this is a rather imprecise approach, and we have to be aware of that when we decide to use estimation. A note of caution about accuracy and precision when we're estimating is that we need to consider what is the unit, the incremental unit that we're measuring, such as grams, and what that means relative to the plot that we're using. In a 1/4 meter squared quadrat, 1 gram calculates out to equal 40 kilograms per hectare. In a larger plot, 1 gram doesn't represent as much. It represents 10 kilograms per hectare. The reason this is important is that we may not be off by just 1 or 2 grams. Let's say, for example, if these students here are estimating the weight of this biomass and they're off by, say, 10 grams, that's 400 kilograms. Now, estimation can be very difficult to do, so even if you're only off by a couple grams or 5 grams, that would be 200 kilograms of grass biomass error that you're making per hectare. And so we do need to be aware of the potential sources of error when we are estimating. So to conclude, harvest and estimation methods are the basic approaches that we use to determine plant biomass on rangelands. Our choice of methods depends on the objectives that we have for sampling and knowing how the data are going to be used. We will often combine harvest and estimation methods into double sampling approaches to estimate biomass on rangelands, and that's the subject for the next lesson.